we see here two functions, f of x and g of x. F of x is in factored form, while g of x is in standard form. In the past, we converted factored form to standard form. This time, we want to know how to convert standard form to factored form. How do we do that? First, let's take a look at these graphs. Here's the graph of f of x, and here's the graph of g of x. We notice that they're in the same exact spot. Therefore, f of x is equal to g of x. And we say that f of x is the factored form of g of x, and g of x is the standard form of f of x. So now, what we want to know is, how can I convert g of x into f of x? How do I do that? So to convert g of x to factored form, we need to know the zeros of g of x. Because if we know the zeros, then we can write the factors. So we need to know how we can determine the zeros based on the numbers that we see in this equation. Okay, so let's investigate. So first, we know that if the function is in factored form, we can identify the zeros right away. So for f of x, we can see right away where the zeros are, and that's going to be 3, -5, and 2. But if we look at g of x, we can't identify the zeros right away. It's not obvious in the equation. So we have to do some investigation, some unveiling. All right, so let me just change my color here. In the standard form, 30 is called the constant term. And the number here in the front, which we don't see, we know that that's 1. This is the leading coefficient. Okay, so let's investigate first the relationship between the two. So let's find the factors of 30. And we put under the factors of 1. We know that the factors of 30 are 1, 2, 3, 5, 6, and 30, while the factors of 1 is just 1. So now if I divide 1 over 1, I'm going to get 1. If I divide 2 by 1, I get 2. And then 3 by 1, I get 3. So I'm going to get 5, 6, 10, 30. I forgot 10 in here. So these numbers, we call this the ratio of the factors of the constant term and the leading coefficient. If we take the positives and the negative of these numbers, so positive -1, positive -2, positive -3, positive -5, positive -6, positive -10, and positive -30, then we have a list of numbers. Now, let's compare this to the zeros. Look at the zeros here. This 0, do we find it in our list? Yes, it is. It's here. How about -5? -5 is right here. And 2 is also in the list. Okay, so here we see that if we get the factors of the constant term and the factors of the leading coefficient, and we get the ratio between the two, then the zeros of the function is one of the numbers that we generated. So all we need to do now is find out which one of these numbers are zeros of the function. So in order to do that, you'll have to find f of 1 and see if it is equal to 0. If it's 0, then 1 is a 0 of the function. If 1 is not a 0, then we will try to find f of -1. and then f of 2, and then f of -2, f of 3, f of -3, and we want to do this to find out which one will give us 0. Whatever gives us 0, that's the 0 of the function, and therefore we will know what the factors are. In the past, we also looked at how the sign changes. See here, there's a sign change from positive to negative, and then from negative to positive. So that means there are two sign changes, meaning there should be two answers that are two zeros that are positive. So knowing that will help us determine which numbers to try to give us the zeros.